Okay, this is one of the shafts. And this is an example of something that we see in other photographs and so forth. This shaft in person, after I cleaned it up, it looked perfectly good. In the photograph,
Just realized
it. You know, obviously all the rest bits. Now, the decision that I made on this clock was not to remove all the metal until I got down to highly finished, but until I could highly finish it. It was to leave it as original as possible. These shafts were always painted in these clocks, and almost nobody who restores them paints them. They will occasionally lacquer them in clear lacquer and so forth. But that's not the way they left the fact protected from the environment that we see they were subject to in the earlier slide, namely the pigeon poo up to your knees. Along those lines, just informationally speaking, Howard offered this movement in more than one grade. This is the lowest grade. This would be the commercial grade. They offered it in a presentation grade that was frequently a tan or a tannish or butterscotch color with a lot more stenciling on, a lot more paint, et cetera, et cetera. In those particular clocks, they would nickel plate the shafts, and they would nickel plate the pinions. Pinions are normally brass in most E. Howard clocks. They did it that way, I think, because that allowed them to use that as a knockoff that could be done in the tower. You could knock off a defective pinion after it was worn and knock on a new one and never take it out of the tower. So it offered repairs on site, which is advantageous when you're in the tower clock business. But anyway, they did offer it in presentation grade. I have not seen one of those in person. I do have photos of one. I have also, at one time or another, received a pinion in duplicate that was nickel-plated brass that was badly worn. So the nickel plate did nothing other than prevent the shafting from rusting and look good. But, it was something that they did offer. If you come across one, it's rare. One of the things on that last slide, we don't need to go back to it, we're fine. I cleaned the rust off using a combination of files, emery paper, stainless or steel wool, and finally ended up with stainless steel brushing notes and things like that. So it's just a hand process, but it cleaned up pretty well. And we'll see that in some others. I mentioned earlier that obviously the pinion is very worn. It's worn more than halfway through. Now, if that were not rusty, that would probably have knocked off. But as rusty as it was in the shaft, or as much rust as there was under, brass isn't rust, but it was enough that the shaft had expanded to the point where it wouldn't come off without splitting it. I have both that and the third wheel pinion outlaid on my table, which is H4, if somebody wants to go look at them, just for grins and giggles. It's not uncommon. Those are usually the two pinions in these clocks that are worn. Usually the ones further down the train will wear slightly, but not a great deal, unless somebody's got creative and put grease on the pinions and the wheels or something to try to get it to run. As we all know, grease on clock gears is not a good idea, and it's even less a good idea where there's a lot of grit flowing around them, and they're all favorite pigeon. All right. And you can see how it cleans up. You can see that the pivots themselves cleaned up quite nicely. I didn't really lose any diameter. If I lost anything, it was no more than a half a thousandth. So, it was something they were ugly, needed polished up and so forth, but I didn't lose much. This is where the gear itself, the pinion fits right on here. And again, you can see that I painted in black, etc. So nothing really exciting going on there other than a little bit of the after, the taste of the after. Okay, here we can start to see some of the problems with the legs, and the back side of the legs still had a lot of dirt in them and so forth. It was buried up to right about here, and actually this was a matter of wire brushing and so forth, power wire brushing, angle grinder just to clean it off. What I really did was save what I could further up the angles, if you will, of the thing and so forth, and down below I repainted it. The repaint that was done in several colors of Rust-Oleum, to be perfectly truthful. And it's oversprayed so that it kind of looks like it all belongs together. If you look at it closely, you'll see there's some black and brown on top of the green. And that's again to kind of make it all look like it belongs together. If you look at it closely, you think, my God, that's a horrible job. This guy is not a painter. But all in all, it carries the day is how it looks. And that's what we were really trying to accomplish, was keep it looking like it belongs together, looking like it might have survived for a while, and able to run it. So that was the goal, and I think we accomplished it reasonably well. So, yeah, see a little bit more of the rust and so forth. But again, here you see the same thing. Fortunately, the pinions weren't all that rusty, even though they were pretty well bound up in the shaft on the strike side. They weren't really rusty. And that was the salvation on this because, you know, rather than turn it down 20, 30, 40 thousandths and have to rebush everything, it was a matter of polishing it up and put it back together. So anyhow, how I did this, and we'll get into that, I guess, in the next slide a little bit or whatever, is, you know, there's 2 or 3 or 4 ways you can get rid of the rust that's like this. Of course, something you pick around and so forth. It's not something you can throw on your ultrasonic and hope for the best. There's at least, well, 3 ways that I generally will clean something like this. I say chemically cleaned, I actually acid clean that. I use nothing other than muriatic acid, submerged in muriatic acid for a period of a couple hours. When it comes out of muriatic acid, you obviously have to neutralize it. But then I wire brush it. And quite honestly, I was using a wire brush and a jeweler's polishing machine, 3,400 RPM. It took me about 15 minutes after, you know, and that's all it took to really do this. It was something that people say, oh, no, acid, we can't possibly, that doesn't make sense. Well, your other choices like electrolysis or something like that, or just plain wire brushing it to death. And the acid doesn't really harm anything as long as you get it clean. After you take it out. If you left it in there for a week, it might, in fact, do something you don't like for a short period of time. It's excellent cleaning rust. So that was what I did, how I did it, and I think the results probably speak for themselves. So I'll leave that one up to people who are more chemistry-minded than me to decide. That's what I did, how I did it.
You mentioned, what is the base metal?
Base metal is cast iron.
Cast iron?
Yeah, of course you had steel in the shaft, but again, you see, pivots were not all that bad. I'm very fortunate that was got a little bit of pitting there, but not much. So after a little bit of time, this is what it looks like. Again, Rust-Oleum, professional grade out of a spray can. Not particularly sophisticated, I can tell you, it's been hours, you know, duplicating the original paint and, you know, blah, blah, blah. But I'm too old to lie about stuff like that. even mistell the story. Anyhow, if you would. Okay, center shaft. This is obviously fairly critical because you know, you've got 60 holes around this ring, and you've got this little mechanism over here, this spring loaded, that allows you to set the clock at the correct time. It actually connects through the linkage up to the distribution network to the dials that are outside of the building. And if you keep all those hands synchronized and so forth, obviously to set the time, all you have to do is pull the pin out here and rotate the whole mechanism around at the correct time. And if you're fortunate enough to have a setting dial on it, you can tell from inside what time it is and set it accordingly. That's one of the reasons that most tower clocks should have a setting dial, because if you fast forward and backward, something way back machine that 100 years ago didn't have radios to talk to the guy outside and tell you what time the handset. So anyhow, this is a fairly critical little piece. I think the next slide will show you, yeah, there you go, cleaned up and so forth. You will see a little bit of wear in the center shaft pinion. I looked at it, and I checked it, and decided to leave it alone. It was something that the clock runs fine without it, you know, without replacing it. Again, it was, the goal was not to replace everything inside, it was to get it back on the road. So I cleaned up quite nicely. Okay, this is more of the misery. And again, for the people who are not doing clock repair and so forth, this probably is redundant, but you know, I have to cry about how bad it really was, so that I get proper credit for what I did. Anyhow, yeah, I'm low on jokes, I'm sorry. But anyhow, you can see that this was, if it sat outside a couple, 3 more years, it might have $28 at the junkyard might have been worth it, you know. But here's the after. You know, that's part of what we want to talk about today. Is this stuff isn't all that hard. It's just a matter of applying some manual labor and so forth to what you got. And we can talk about some of the machines I used and things like that a bit later if you want to. Some may be interesting, but it's not high tech in any way, shape, or form. Okay. Now, the verge was missing along with the crutch and so forth. And this is actually a pattern out of the Howard factory. It happened to be for a number 0 tower clock. It's also for a number 0 chief of street clock. And it was a pattern done in pewter, so I actually firstly laid it down and just traced around it. And, you know, I mean, I can make a version of readily that way, but there's some other things to be considered when you're doing that. Is I have a couple of machines that will actually machine parts off a drawing. And being a lazy person, that's actually a better way to proceed, in my opinion. And I would also encourage everybody in the room, if you're doing anything at all about building parts, some of those simple CAD programs and so forth for our computers are well worth consideration. I use nothing other than AutoSketch. TurboCAD is another one that's available for darn near free or something. But I would really encourage people to do that because it's kind of getting us into the next century, if you will, or out of the last century into this century. Basically, just doing the measurements and so forth is, like I said, I can make a verge for at least the plane. So, yeah.
How did you come by the pattern?
Happens to belong to one of our members. There was a whole lot of stuff that came out of the Howard factory when they closed it down. And a fair amount of that migrated to Houston one way or another. A lot of photos migrated down here. Several Rose engines and so forth migrated down here. And a whole bunch of parts. And I was privy to where those parts were and got myself into them. And actually, Don ended up with the photos, et cetera, et cetera. And the Rose engines went to David Lindow and some things like that. So, by the way, one of the Rose engines still had a pendulum bobbin for Howard number 70 that they never finished and they closed down the factory. I thought that was kind of interesting. Anyhow, by drawing this, in this case on AutoSketch, you can get some very accurate dimensions. It'll tell you what the dimensions are. If you say measure from here to there and so forth. And it tells you some things like that pattern. It's not exactly symmetrical, if you will. Now, one thing, the pallets are curved when they're clocked, so this surface right here and here should be a radius from here to here. It shouldn't be a square surface. And, I can redraw that very quickly, and the machine will go off and produce it with a curved surface there at the proper radius. That's a little more difficult to do by eye or whatever. But, it's something that, again, I really do recommend people consider if you're building something, at least consider some of these simple, computer-assisted drawing programs and so forth. I started off using those about 30 plus years ago. I've always used 2.5-axis sorts of drafting packages. I've never gone from the 3-axis or the solid geometry packages. I haven't had to. Unfortunately, that leads me to a point today that I haven't grown where I really should be with today's technology. I have access to a 4-axis machine in my garage. I only use 2 axes of it because that's what I need, but I really should be able to use those other 2 axes, and it's because I haven't learned the software package. So I need to go off and educate myself. I'm too busy playing with tower clocks. Now, same thing on the crutch and so forth. These, again, very easy to mention and so forth. Feed it the drawing, and the machine actually goes up and makes it apart. That's kind of neat. Obviously, you have to clean it up. You have to do some manual operations with threading and things like that. But, that works out quite nicely. Some things like this, to hold the verge that was missing, these brackets, just a manual operation, L brackets. We'll talk a little bit more about those 2 L brackets and how 0.010 of an inch in height makes a difference between a clock that runs and a clock that doesn't. Like I said, we'll talk about that pretty soon. Suspension spring and so forth. You can't run down to time savers or any of the rest of the people and buy one of these suspension springs. So you need to make one. And it's not as easy as one might think. Again, it's fairly simple technology and so forth to keep it square and keep everything symmetrical and so forth. It gets to be a little bit more difficult. Now this particular clock over here, since running, has a suspension spring made out of alarm clocks, mainspring. I didn't have any, I needed about 20 thousandths or so thick material in ship stock. I didn't have any. I discovered I had an alarm clock spring. It was fine. The clock doesn't care. But The rest of the suspension spring is true to what it should be. You know, it has a chock at the top of it that actually sets across the suspension spring to get to the point where it bends, which makes it slightly more accurate than if you just let it bend wherever it wants. And it changes in temperature and so forth. It affects your timekeeping more than if you have some chocks in it. So that was something that a number of tower clock makers did. Anyhow, other construction projects, the grating nut and so forth in the bottom of the pendulum, the assembly that holds the bottom of the pendulum, you know, again, just basically all handwork. I drew these years ago and I've used them several times since. You know, just other people seem to want them, et cetera, et cetera. Nothing of any real consequence here. So, anyhow, bevel gears. I made one bevel gear for the clock back there, and that's what's actually the setting dial. You know, basically, to put that clock back in operation, I'd have to do another two. There's one that's original in the mechanism, as you can see in the back. It's not particularly difficult to make one of those. It's like cutting the other gear, only you cut it at 45-degree angle. It's as simple as that. I do cut a lot of gears, so that's not particularly a problem. It's just a little bit about the geometry, a little bit about how I did it and so forth. I think the next picture will show. No, it's there. This is my very sophisticated depthing gauge, if you will, the piece of aluminum that's also out on my table. What it really amounts to is like any other clock, you need a depth escape and you need wheels. I have 3 depthing tools that are proper tools. Of course, none of them are good enough to handle a tower clock. So I crafted this nice word. I cobbled it together out of junk. And it actually has a slide that goes behind here that allows you to set the depth. And of course, then you go back to the clock and you measure from here to here, and that's how tall you want those little brackets I told you. 10 thousandths made all the difference in the world. I know that because I got 20 thousandths too short. But again, that's skill and ability. You know? How not to do something is really more likely. So anyhow, it's out there if you want to look at it. Okay, there's the pendulum as it evolved. I have one of these blanks for the keystone laying on the table out there again for your review if you'd like to look at it. It's 1/4 inch plates, nothing sophisticated. It's plasma cut, CNC plasma cut. I guess I'm in love with CNC when it saves me time and effort. I mean, to sit down and whack that out of a 1/4 inch plate, I can do it, but I really don't want to do it. If I got a machine, will do it for me. Same with the bob, that's cast iron. The worst part of that was drilling a hole. You can get blanks of this stuff from people like the Master Car. You can get it the thickness you want. You can get anything from probably 1/2 inch diameter all the way up through about 8 inch diameter. It is remarkably expensive. The worst part of making the bob is drilling a hole. And the hole is actually, I think, 1 inch in diameter at the top. And at the bottom, it's 3/8 of an inch diameter of the shafts. That was the way Howard built it. Just my effort to save time. Okay. Cutting pinions. This is how I cut the pinions. You can see I'm cutting multiple pinions. It's a Tormac machine, CNC, 4-axis cutter, fork cutter, just a standard conventional fork cutter. And I cut them generally full depth in one pass on this. You'll notice I am using both lubrication and coolant. There are people who will say you never need to use coolant on brass. Old-time metallurgical engineer who was one of my early mentors beat me about the head and shoulders on that particular point. He'd been cutting metal for 60 years. By the way, he was a fellow in the organization. I brought him in, and 2 years later, he's a fellow. That means something. But he said, coolant and lubrication on brass, and I've saved a lot of windmills that way. You can cut wheels like this without it, but it's easier. It's on the machine. You can cut them faster. You can cut them with less wear on the tooling and so forth. So it's just messy. But anyhow, that's my speech on coolant. Okay. Also missing was the rack. Now this was fun. Making the slide from the rack, a piece of brass, no big deal. You know, just cut the slots and you're in business. Putting the teeth on, a little different. Now you'll also see out of my table several false starts and quick stops. I did it in aluminum originally. And my first couple, I discovered that you should divide by 12, not by 15. Don't ask me why, but that's something that making a rack is not particularly difficult, but you need to think it through, and you don't want to do it late at night or when you're low on coffee. That's my only excuse. As a matter of fact, to measure the amount of distance a rack needs to travel and therefore how far each teeth should be spaced apart is no big deal. You drop it down to the lowest point, measure how far it's traveled back and forth, then bring it back to 1 o'clock and see how far it travels. And you've got 2 dimensions. And the difference between those 2 dimensions, obviously, how far it travels. Okay, we need 12 teeth in that, so you divide it by 12 and it tells you what the pitch is on your spacing. Except when you divide by 15, then it doesn't work. Not only did I do it once, but I did it twice. Okay, you will also notice those are pyramid, they're triangular shaped rather than the conventional tooth shape. You will find one of them out on the table that is conventional tooth shape. This thing wanted to lock up intermittently, and I don't know specifically why yet. There was something about some of the geometry here wasn't quite right. It works perfectly well with the triangular shaped teeth. It doesn't work perfectly well with the traditional shaped teeth with the straight and the curve. I prefer it look correct, but again, Mr. Fulbright was beating me about the head and shoulders, demanding I work for free, giving me enough beer, et cetera, et cetera. And so he ended up with what we ended up with here, and it works fine. More detail on that. You can also see out of focus where I silver brazed the new arm on the stub where it had broken off. Again, something that could be cleaned up more. If I'd known I was going to buy it, I would have done a better job. And here's some befores. here's what I'm talking about, type of stuff. And anybody who thinks this is easy needs to be at least full of coffee. I spoke earlier about cutting the bevel gear. This is just cutting the bevel gear. This is using an involute cutter, as a matter of fact. Chinese-made involute cutter. $125 for a cutter, $7 for a Chinese-made cutter. Problem being is they're involute rather than, epicloidal, which actually is generally epicloidal in their teeth. So, but for cutting the bevel gears and so forth, the involute gearing was just fine. Look at it over there to see what you think. Okay. The weight that came with this block, I thought, that's a Howard Bob off of one of their big movements. And it is a Howard Bob off their big movement. This is actually about 100 pounds, maybe 90, whatever. I haven't weighed it, but it's a chunk. It's threaded at the top, and it has a screw-in fitting at the top. So it came out of Howard as a Bob. I mean, that was their intention. Or somebody who had access to a very big tap and die, or whatever made it. I suspect it came out of Howard's that way, would be my guess. And it's at least an educated guess. Certainly, if anybody has seen any others. And one of the tower clock guys did tell me he had seen one other clock with this. Kind of interesting.
What's the dimensions of that thing?
About that big, about that tall.
Let's compare them to the tiny cat.
I knew that was going to come up.
Would you believe my wife's website is cathappy.net? Would you believe that? I won't say that. It sounds like a commercial, but I won't say that.
They're great storage, and they're free.
Yeah, they are. Anyhow, this is some of the stuff that was made, is the rating down at the top, and I put a scale on it so you can tell where it's at and so forth. You can see right there a 0 stamped into the top frame. And, again, here's the spring we talked about, the chocks. And here's the crouch assembly and so forth that built from, the drawings and so forth. So it's just basically a matter of putting back what Howard would have done originally or what they had done. I've had enough of these to know what they should look like. I have pictures of many of them. So it's just a matter of making the parts. So a little different picture of it. Of course, there's the verge we were talking about earlier. You will notice a slight curve there. And it's not curved as much as it started off. I had to straighten those up a bit. It runs. So, and again, you can see the 0 up there from the serial number. And we looked at the drawings of those, and that's, shortly after it came off the mill, haven't squared off any of the corners or anything like that. That is one of the disadvantages of CNC is, these parts would have had square corners here originally. Obviously, have the radius of the mill that you use to mill it out until you square it out. So I will generally square those up so they look like they belong. Okay, setting dial and so forth, as well as the fan assemblies. Start seeing it come back together a bit here. You can see the rust pitting under the fan and so forth. But again, decision we made. The hands are made out of spring steel. I made them big and bulky so you can see them across a fairly dark tower or something like that. The dial is brass engraved. Obviously has, wax filler and is silvered and lacquered after that. Those are also something that my CNC machine does from the drawings. Is little dials. It'll do the hands too, but the dial is something I feed into the drawing. It cranks up hard for me. It's a lot better engraver than I ever would be. There is a blank dial that's engraved out on my table here at age 4 if somebody wants to look at it. See one that isn't filled, just see it as it comes off the mill. The bad news on that is about 33,000 lines of code to do a dial. The machine does it all on its own if you have to edit it. It's to be a bit cumbersome. Fortunately, I didn't have to edit that one. So, but I couldn't get it to put E. Howard across the front of it for whatever reason. Would not do it. It's also the programming path will not recognize an ellipse in a drawing. Now, why will it not recognize an ellipse? No, it doesn't. So anyhow, you have to draw funky circles and connect them together. And that works. So here you can see the bevel gear that was created using the end loop cutter from China for $7. And a standard motion works, the same stuff that Howard generally used, the same gearing, the same size, and so forth. That also would fit a Howard 780, would fit a variety of other clocks that Howard made, so they'd use something off the shelf. So frequently you will find these kind of setting dials in a brass can. And of course, again, that's to protect it from dirt, et cetera, tower. I didn't do that. Ben was getting really cheap by then. He's not smiling. I could be in trouble. Anyhow, this is kind of as it went back together and so forth. And you'll see that the paint on the bottom and so forth, I saved the original paint as best I could. I did overcoat it with some satin lacquer just to preserve what was there. It was kind of getting a little bit flaky. I don't like the shiny look. I could have put the shiny look on what's above, but I didn't. The frames and so forth were pretty much cleaned down to, let's say, iron oxide, if you will. I didn't get crazy about cleaning them up, but I did take it down. They were well rusted and so forth, so they have no original paint on them. And this paint is like what I did to the legs. It's several coats of several different colors. You see some black on it, you see some brown and so forth, all sprayed on intentionally just to kind of make it look like it belongs together. And again, you can check it out back there. The other side of the thing, ready to go. I had it running on 4 paint cans a year. I just cobbled those legs together to bring them over here. So anyhow, it's up and running. And as you can see, it runs reasonably well. It does strike. I have the strike more or less disabled over there. The strike weight is not really sufficient to compound it. And it only runs about 6 or 7 hours on compounding the strike side. Okay, in conclusion, somebody asked me to repeat all that. I'm going out to lunch. How hard it is, it's basically like eating an elephant. Why did I think there's another one yet. Okay. This is a collection of Don View, and it's a photo of some of the Howard workers about probably 1890, probably before 1900, I would guess. And I think probably we should at least honor those guys because they built a really decent clock. They built it, probably under some circumstances we would find pretty difficult. I think that's about it. I have some pictures of machines and so forth in here. If there's any questions, I'm certainly open for questions. We will kick it around after the group. Yes, sir.
Go back 2 slides, I didn't finish talking about it.